Bismillahirrahmanirrahim. My name is Wafa Rahman Wafa, a PhD student under the supervision of Dr. Amir Hamza Sharai, student at the Department of Environment, Faculty of Forestry and Environment, University of Putra, Malaysia. And today I will be explaining about the LCSA in the lecture series of LCT Life Cycle Thinking. Our topic is Life Cycle Sustainability Assessment, and we will focus on life cycle sustainability assessment in this session. We will explain about the sustainable development, what is sustainable development and how it comes from, and the benefits of sustainability. And also we will discuss about the life cycle sustainability assessment in the 3 dimensions of sustainability, and also we will focus on how to conduct LCSA, life cycle sustainability assessment. That we will discuss about the how to do such an assessment for a product or process to take the decision. And at the end, I have provided the reference list which will provide you the list of references, the resources that are used in this lecture, and this is for your further reading. If somebody want to read more about the sustainability and life cycle sustainability assessment, these resources can be helpful for them. At this session, students should be able to demonstrate the concept of LCSA, the concept of life cycle sustainability assessment. And secondly, students should be able to design a LCSA for a product or process in line with a certain guideline. And actually, the word sustainable in the first time, it's this term sustainable was used in the modern science, was a part of the Club of Rome in 1970. This came to force as a part of the publication of Limit to Growth, a report that described a particular state in which the global population would achieve balance or equilibrium. This term used for the sustainable, how to reach the world population to the equilibrium. The word is searching for model output that represent a world system, and firstly the sustainable without sudden and uncontrolled collapses and destruction of the environment and resources. And secondly, that world in nature will be capable to satisfy the basic material requirement for all the people, for all its people. So the word sustainable come in that time in 1972. After 15 years of the Club of Rome's publication, the World Commission on Environment and Development, WCED, was assigned for a task from the Secretary General of United Nations in 1983. The job of the WCED was to re-examine, to reanalyze the critical environmental and developmental issues worldwide. And actually they will formulate an actual proposal to address these issues. Actually, this communicated in 1987 Berlin Report publication of Our Common Future, which is published by the Oxford Press, and they have give as such a definition to the sustainable development, which established a suggested path for the sustainable development on a global level, and serve to broaden the concept of sustainability in the international level. They give the definition of sustainable development, the sustainable development that the sustainable development is development that meet the needs of present without compromising the ability of future generation to meet their own needs. It means that the world people will use the resources in sustainable manner. They will consider the need of the next generation, the future generation, because we are doing developing, we are using the resources, but we must consider the need of the next generation. The resource must be available for the next generation also. So that's why the sustainability identified as the guiding principle for 21st century. All of the organizations and countries are committed to consider the sustainability in their project and their processes that they to achieve the goals and to reach to the sustainable development. Here's the three dimension of sustainability. Sustainability actually come from three dimensions: social, environment, and economics. And these three dimensions, they are integrating in each other. The integrated part is the sustainable development. The integrated part is the sustainable development, and they are if a product is acceptable socially or environmentally, but economically it's worse. So this is not sustainable. So this point of integration is sustainability. And now we reach to life cycle sustainability assessment. What is LCSA? LCSA actually, this is the combination of three assessments: a life cycle assessment, LCA, and life cycle costing. That in the previous lecture, the information provided of life cycle costing, one of the LCC, ELCC, and S-LCC. So the life cycle costing is the second dimension of life cycle sustainability assessment, that we must conduct the life cycle costing research and assessment as well. And the third one is social life cycle assessment. And then when we are doing an assessment of life cycle sustainability assessment, we must consider the social aspect as well. And thirdly, it's all the combination of all assessments has come to life cycle sustainability assessment. This model provided by the Klopfer in 2018. Actually, life cycle sustainability assessment refer to the evaluation of all environmental, social, and economic negative impacts and benefits in decision-making process to a more sustainable product throughout their life cycle. This is also this definition also provided by the Traverso et al. The LCSA is a method for evaluating the performance of the sustainability of product while considering the life cycle, environmental, economic, and social dimension in this. Here is three dimension of sustainability that we discussed before: the social, environmental, and economics. Actually, the sustainability, the LCSA has come from social life cycle sustainability assessment, has come from social life cycle assessment, and life cycle costing. The benefits of LCSA, why we are doing LCSA? Each of the assessment and analysis must have their benefits for it have objective and purposes. What is the rationale and what is the benefits and importance of the life cycle sustainability assessment? First of all, LCSA enable the practitioner to organize complex environmental, economic, and social information and data in structured form. They are collecting the data about all three dimension: social, economic, and environmental, and they bring it in a structured and combined form. LCSA promote awareness in value chain actor on sustainability issue, which issues must be considered for the sustainability and product process. NCLC assists decision makers to choose sustainable technologies and product, which product and technology is more sustainable and sufficient. And LCSA will show enterprises how to become more responsible, more committed, more competent for their business by taking into account the full spectrum of impact associated with their product and services. LCSA can support consumers in determining which products are not only cost efficient, eco efficient, or socially responsible, but also more sustainable. The consumer also, they are taking decision about the product that they are consuming, they are using. So which product is more environmentally friendly and more socially responsible? So the cost is also included in this. LCSA stimulate innovation in enterprise and value chain actors. They will process their product in an innovative way. So the LCSA will make them applicable and committed to bring changes and bring a sustainable product. LCSA has the potential to inform labeling initiative and communicating transparent LCSA information help enterprises to raise their credibility. Their credibility will be highlighted in the LCSA assessment. Now we reach to how to conduct LCSA for a product or process. The procedure used to determine the level of sustainability of a product, process, or service were as follows. The first, we will carry out the LCSA using the methodology as described by the ISO 2000A and 2006A and also ISO 2006B. These two guidelines is helping in the conducting the LCA methodology. The second will be using the LCC, how to conduct LCC using the LCC methodology as shown by the recent code of practice and LCC are mostly used and they are using the NPV equation, net present value. So it will help for conducting the life cycle costing. And thirdly, we will perform the S-LCA using the methodology as explained by the UNEP-CETA guideline for social life cycle assessment of product and process. And lastly, determine the LCSA by combining these above three assessments, the combining of LCA, LCC, and S-LCA using the scoring system. The scoring system will help how to combine these three dimensions and make LCSA assessment. LCSA framework, LCA framework based on ISO 14040, ISO 2000. So they define the four phases in four steps. The goal and scope definition, which is explained by ISO 14040, inventory analysis ISO 14041, and impact assessment ISO 14042, and interpretation and 14043. These all framework is adopted in LCA, LCA, and also in LCC, and also in S-LCA. The first step that we conduct a life cycle sustainability assessment, the first one will be the LCA. The LCA, the first we will determine the functional unit. That functional unit must be a t-shirt, a meter square of building, a single fan, or a production of a bottle of water. So these unit we must consider how much resources used for this unit from cradle to grave. And now we reach the system boundary. The system boundary must be a cradle to grave or a cradle to gate or a gate to gate or a gate to grave studies will be conducted. For example, that we are using a bottle of water, the production of bottle of water, from which resource used in this product. This is from cradle to grave, from raw material to the transportation to the firm, and the firm to the packaging, and after that to the consumers to using, and after use to the disposal period, so that we will consider all the stages until the whole life cycle of the bottle. So we consider these system boundaries. It's depend on the study. If a study or a product start from cradle to grave, cradle to gate, gate to gate, or gate to grave, so we must consider, and we will calculate all the steps and all the periods of the life of the product. Some of the software are available that they are calculating the LCA impact assessment. They are calculating LCA. The most useful is SEMA Pro, is user friendly. Magabi and OpenLCA is also used, available and openly, freely. But SEMA Pro and Magabi is costly. It will be in price. LCI method in LCA is used by 14,040. The mostly used eco indicator are by authors. And the result, we use the result for ISO 14043. They are interpret the result of the LCA product. Now the life cycle costing usually carried out in 4 phases that we mentioned before in the framework of LCA. It's also adopted in LCC. You aware more about the LCC in the previous lecture. The life cycle costing usually carried out in 4 phases. The first one is goal and scope definition, which will determine the borders of the system as well the unit that cost accounting effect. And second, inventory costs. Collecting economic data will enter into an Excel spreadsheet model, and we will calculate the all cost. And the third one is aggregate cost by cost categories. There is no comparable impact assessment phases in LCA. And the fourth phase is interpret the result, similar to that of an LCA. And now in the life cycle costing, the simple formula using from NPV that we are using mostly net present value. So the first we are calculating for a product or process the initial cost. The initial cost we are using, and then we are using the operation cost plus operation, and the operation cost plus all maintenance, repair, refurbish cost, and plus the disposal cost of a product, and plus the residual value. The all values in the all cost we are calculating, and it will give us the life cycle costing in all the cost level. Now we reach the social life cycle assessment. LCSA is a social impact assessment method that aims to assess the social and socioeconomic aspect of product and their positive and negative impact along their life cycle, encompassing extraction and processing of raw material, manufacturing, distribution, reuse, use and reuse, maintenance, recycling, and final disposal. This definition is based on the CTEC, UNEP CTEC in 2019. This provided this definition for the social life cycle assessment. It's also goal and scope definition, inventory analysis, impact assessment, and interpretation of the result of the social life cycle assessment will consider. We will take the categories, and we will take the subcategories, and we will discuss about collect the data about the indicators, and then we will interpret the impact assessment result and the interpretation of the result will be carried out. Now, life cycle sustainability assessment comes from before that we discuss. According to the Guni et al. 2011, he says the life cycle sustainability assessment or an LCSA is a full-scale assessment of the social, economic, and environmental components and the relationship within a system. A more mathematical definition of the LCSA can be throughout of as follow: LCSA plus environmental LCA plus economic LCC plus social LCA. It is defined by Guni et al., which is comprised for we visualize in the below ELCA plus LCC plus S-LCA. It's the integration of all is the sum of all is LCSA. Life cycle sustainability assessment requires a multi-criteria evaluation to address the balances of indicator as well as the weighting between them. In studies of S-LCA, it has been assumed that each dimension, environmental, economic, and social, has the same weight, but the indicators chosen have different percentage of contribution to the global sustainability of the system studies. So actually the sustainability assessment is a multi-criteria based on its conduct and based on the multi-criteria decision analysis, which we choose the best option for a product or a process. Mostly used for the life cycle sustainability assessment is the scoring system. The scoring is mostly used to assess the LCSA for multi-criteria decision assessment. The first step, once obtaining the result of LCA, LCC, and S-LCA based on the guidelines, we conduct the LCA, LCC, and S-LCA. The value obtained for all indicators are transformed to contribution percentage. That value we receive, that we will change to the percentage. Scoring from 0 to 4, in some cases 0 to 1, in some cases is more. It's up to the author and the extent of the studies. They choose the numbering, they give the number are given to each indicator according to the percentage of contribution assigned. And thirdly, the scores of indicators under the same subcategory are average, and this average score are assigned to the corresponding subcategory. And fourthly, the higher score of indicator means greater the contribution to sustainability, and lowest score means lower contribution to sustainability. These score when we obtain, then we will decide about the we will discuss about the sustainability. So this is the life cycle sustainability triangle is used for graphical scheme to illustrate the comparison of two alternatives. Which alternative is most important? So here's the weighting factor of economic WEC, W is weighting factor for social, and WE weighting factor for environmental. The WEC plus WS plus WE is equal to 100%. This 100%, when we receive the 100% for our all study, it means it's a sustainable product or process. So here is some case study that we bring as an example to converting the qualitative and unity data into quantitative expressions. For the positive indicator, the Najat and Sharai 2021, they use for the positive indicator 0 to 20, the mark is 0. The percentage is 0 to 20. For 1 mark, they use from 21 to 40. For 2 marks, they use 41 to 60. For 3 mark, they use the 61 to 80. For 4 mark, they use 81 to 100. This is for the positive indicators, but for the negative indicators, they use 0 to 20 the form for 4 mark, and for 3 mark is 21 to 40, and 2 marks 41 to 60, 1 is 61 to 80, and 0 81 to 100. So they calculated based on the negative. This is for the negative indicators. So they studied for the crude palm oil production. So they studied about these all 3 dimension. Here we see the social, the value of the social dimension is more, the economic is the second, and the environmental is third. So they deciding the procedure, the firm and the decision maker are deciding about the sustainability, about the product improvement. For example, here is the socially is the most socially acceptable, but here is a problem, a little bit problem. It's need improvement in environmental sector. They must consider some environmental issues to reach to the sustainability, because the greater is to the fourth, the greater mark will be they demonstrate the greater contribution in the sustainability. So here we see the 3.7, the social is mostly contributed in the sustainability, and the economics 3.2 is the second contributed, and here we see the 2.5, the contribution of the environment is less. So the firm will consider to improve the environmental issues in their production and services. Another example is from the Vinyas, Oliverasola, Ogaya, Redwell, and Gasser 2013. They also studied, so they give some 3 models. They give 3 model of the sustainability, 3 studies. So for the 3 model they are considering, for example, for the total score for LCA environmental and LCA for costing, S-LCA social. For sustainability factor, environmental sustainability factor 82 for the DTD, and for the environmental factor for the DTD, it is for actually they studied about the used cooking oil is a domestic waste generated as a result of cooking and frying food with vegetable oil. So they, for the waste collection system, they are studied, and they for the sustainability, the purpose of the study was to compare the sustainability of the 3 domestic collection system. Actually, the one DTD is for door to door, the ACH for through schools, and UCC is based on the urban collection center. So they calculate the each of the collection system, and now they give the figure and the graphic visualizing the sustainability contribution of each sustainability factors, the each dimension of the sustainability. Here we can see in this place we can see the sustainability factor of environmental. It is about 82 for DTD, and for the social factor, sustainability factor of costing is 0.2, and sustainability factor of social is 1. Here we can see DTD in blue color, and this is the social, it is 100%, it's they reach to the 1. But for the cost, for the sustainability costing, there is 0.2. They're the marks they take, they give the points, and for the environment they receive 82. So the contribution of social is more, and secondly the environment, but economically the economic factor is very here is a problem. It's not contributed more in sustainability. And for the other case, school, through school, so from through school, we see for the environmental sustainability factor, it's take about 65%. And for costing 1%, it's not, sorry, it's not percent, it's 65 marks they take the in the weighting. And the sustainability factor costing 1, it's 100%, and the sustainability factor social is 0.97. So it's mean the socially and economically this is sustainable, but the environmental contribution is less. And the third one is through urban collection center. So the urban collection center that we see, the sustainability factor of environment is 100% contributing in sustainability, environmental dimension. And for the sustainability factor of costing is also 1. It's also 100%. The cost is also 100% contributing in the sustainability. The economically it's also sustainability. They're contributing in the sustainability very well. And socially it is 0.8. This is the less contributing than environment and economic factor. Okay, in this case, in this scenario, is 3 issues. Which one is most sustainable system? So the decision maker is taking decision about this model. For example, so now the UCC, Urban Collections Center, this is the most sustainable system. Then school, and then door to door. So the urban collection system will be considered in this case, because this is environmentally, socially, and economically contributing in the sustainability. Yes, in environmentally and socially and economically, this is 100% contributing, but in socially it's 80% contributing. Based on this decision, the decision maker will take they choose the UCC option. They choose this system to implement or to work on. And for the social, here is less. It is not matter. Maybe it will be improved in the when they implement the product process. Okay. This is the visual example of the first that we discuss. Venus et al. In 2012, they talk about this issue, and also the Singh and Rajesh Kumar. They also make an assessment of a sustainability assessment. Singh Rajesh Kumar et al. 2007, he conducted a study about what we say. He studied about the development of composite sustainability performance index for steel industry. They studied about this, and they consider for all of their sustainability dimension. For the contribution of sustainability, they put 5 dimension. OG for organizational governance, and technical aspect is TA, and ENV for environment, SOC for society, and ECO for economic. they consider five dimensions for the sustainability in steel production industry. So they give actual weighting for these about the 10 marks. They mark for 1 to 10. So they are analyzed based on their marks. So here we say the economic mark is 7.6. This is more contributing in sustainability. And the second contributing is 2.7. The environment is also contributing in the sustainability. And 2.8 is social society. The society is also contributing in the number 3. And number 4, the organizational governance is contributing in sustainability, and technical aspect is contributing less. Actually, in this graph we see only the economic is contributing more. The other aspect, the other dimension is contributing less in sustainability. These are some of the example of the sustainability assessment conducted in the world. I used these references for this presentation. Thank you very much for your attention. Terima kasih banyak-banyak.